Hello everyone, this is the tutorial where I am going to discuss the concept of periodicity in case of composite function where inverse is involved. You know, sin inverse x is a inverse trigonometric function, cos inverse x is also inverse trigonometric function. They have their fixed domain and range. You are familiar with those domains and ranges. But here, today's class, I am going to tell you the composite function sin inverse sin x. Sin inverse, you know, sin inverse x is inverse of sin x. So their composition, you will say that they will give the identity function. Similarly, cos inverse cos x also give us the identity function. But you will see some peculiarities in case of some of them, that what way you will get the identity function and whether they are really periodic or not, that you can decide. So this tutorial you can refer as periodic function part 2. Periodic function part 1 we all have done with the periodicity of different kind of function, not only trigonometric, algebraic functions also are involved. Here mainly we are going to do it with the help of the concept of inverse trigonometric function. Let me start with sin inverse sin x. As you all remember, sin inverse x function, that x belonging to the interval -1 to +1, and that sin inverse 1 will go to -pi by 2 to pi by 2. So I am not going to discuss that part. I will be discussing straight the nature of this sin inverse sin x. Let us plot. See the nature of sin inverse sin x. What does it give? Equation of this line, if you consider this is y equal to x, all of you can see that because slope is 1 in this case. And here this one is the line which you can get by rotating this line by 90 degree. If you rotate this by 90 degree, you will get this. Rotate this by 90 degree, you will get this. Again rotate this. So all are coming one by one just by rotating this one, the initial one. Then next one like this. So sin inverse sin x, will you say that it will be x always? And in which case it is x? The sin inverse sin x will be equal to x over this interval. This interval means it is a point in between -2 -1, and then it is between 1 and 2. If you calculate the value of -pi by 2, you will see that it is matching with that. Let me plot y equal to pi by 2 for you. Then let's see what happens. If I plot y equal to pi by 2, y equal to pi divided by 2. Now we take, wait a minute, we take x equal to pi by 2 over there. Make this one absent from there. So we go for x equal to pi by 2. X equal to pi by 2. Why I am taking pi by 2? Just I wanted to show you that it is in the interval between -pi by 2 to pi by 2 where the nature remains y equal to x. Yeah. See, this is x equal to pi by 2. If we go on plotting x equal to -pi by 2, x equal to -pi by 2. Do it, -pi divided by 2. So you will see that the graph is y equal to x between -pi by 2 to pi by 2. So sin inverse sin x will give you identity function x in this interval. Indeed, it's true, because that sine inverse 1 has, sine inverse x has the principal value branch for inverse 1 minus pi by 2 pi by 2. It's supporting that. But the thing is that between this is pi by 2, if I plot it here, it is going to be 3 pi by 2, but the equation is changed here. Next part also equation is changed. So those who are doing advanced study with inverse, they will get some clue there. They can write the equation easily, quickly. My aim is not to write all the equations there, just to show you that it will remain the identity function over this part only, where it is minus pi to pi by 2. Next part it is going to be changed, then it is going to be changed. But every time if you rotate the line by 90 degree, you will get the next one, either clockwise or anti-clockwise. Okay. So this one, sine inverse sine x. Now we'll say that the period of this function, is it a periodic function? Just think. Is it a periodic function, sine inverse sine x? Who can say? This sine inverse sine x, if you observe that this is really a periodic function. I am making these two lines of, I am going to show you that how this one is periodic, and period is 2 pi. You see the graph of the function is repeating over a fixed interval. My aim is to get the length of the interval. This is one full part which is being repeated over there, which is being repeated over there. So if I can find the position of these 2 points, that I am doing by plotting x equal to minus pi by 2 and x equal to 3 pi by 2. So the length you can say is going to be 2 pi. Length of interval going to be 2 pi. Let us plot x equal to minus pi by 2 first. Minus pi divided by 2. Okay. Then I am going to plot x equal to, take x is equal to 3 pi divided by 2. So what I was telling you, equation of this line x equal to minus pi by 2, this is 3 pi by 2. So what is the length of this interval? This is 2 pi. Next, it will also be of length 2 pi. So what the length 2 pi, it is being repeated. So period of this function will be equal to 2 pi. Okay. Let us see what happened for cos inverse cos x. Make this one off. Go for cos inverse cos x. See. Cos inverse cos x function, by plotting the two vertical lines that manner, we can prove that the length of the interval over which it's going to repeat, that you can verify easily. See, this is x equal to 0, this is approximately 6 point something, 6.28 in fact. So what is the length here? 2 pi. This is going to be repeated over there, this is going to be repeated over there. So this cosine x, if you choose the axis along x-axis, if you take it in terms of pi, then it will show you properly. But some approximation there also you have to make, because the length you cannot take arbitrary, length will be pi by 2. So better you realize this length is equal to 6.28. Next also is going to be almost 6.28 to 12 point something, 6.28. That is equal to 2 pi. So over the length 2 pi, it is going to be repeated. So cos inverse cos x is also periodic, and of period 2 pi. Let us see for tan inverse tan x. Is it periodic? Okay, I am coming back to tan inverse tan x. Before that, let us see. This is cos inverse cos x that we have verified. These are two verified things. Let us go for tan inverse tan x. see what is happening there. Is it a periodic function? Tan inverse tan x. The graph looks similar, no? All. So it has to be periodic. Length of period, how to find? Length of period you can find over which the graph is going to be repeated. If you find the length here you see that the length of the period is going to be equal to pi. So tan inverse tan x is period pi. This is C 1 point something and this is 4 point something. That if you subtract it with 3.14, that is equal to pi. So period of tan inverse tan x is pi. Similarly, if you find cot inverse cot x, that period is also going to be equal to pi. Okay. So here our learning is for sin inverse sin x, cos inverse cos x. Similarly for sec inverse sec x, cosec inverse cosec x. All of them have the same period 2 pi. But other functions like tan inverse tan x and cot inverse cot x, they will have period pi. Okay. So all composite function this manner periodic. Sin inverse sin, cos inverse cos, tan inverse tan, they are periodic. But let us see about the function sin of sin inverse x or cos inverse cos, cos of cos inverse x. Are they periodic? Let's start with sin inverse, sin of sin inverse x. What do you expect here? You say that here also I expect x only. And it may be periodic, may not be periodic. But my answer is, it cannot be periodic because sin inverse has a range. I mean sin inverse x has a fixed domain -1 to +1. It cannot go beyond it. See? This graph will never be repeated. So here it is not periodic. Here the domain is -1, 1, but still we are getting the equation as y equal to x. Let us see tan inverse tan x. Is it periodic? Hopeless. Here also it is a straight line only and that is not going to be repeated in a fixed interval. So this is not periodic. Then what about this thing? Not periodic. Cot inverse x also not periodic. Then see next one, sec inverse x. Here there is nothing between -1 and 1. It cannot be there because -1 to 1 it is not defined only. It will be beyond that or equal to that. Beyond 1 or equal to 1. Beyond -1 or equal to -1. So this is also not going to be periodic. It never repeats its graph. So now let us see for cosec. See the same manner. So none of them are periodic over there. Periodic was sin inverse sin x, cos inverse cos x, all these. But these things are not periodic. Their graph will never be repeated. In fact, there is a break which cannot be made up. In between -1 to +1, this function is not defined at all. Okay? Now, I give you some work here which you try to do at home. Is there any possibility of getting the period of some of these two functions, sin inverse sin x, cos inverse cos x? Their sum, if you consider, are they going to be periodic? Okay, this is the question for you I put forward. You must try to solve. If these two functions are periodic, what about their sum? Will this be periodic? In normal class I have explained the concept already, but here I want to see that you all are doing by using this graph. Okay, thank you.